In this video, I will cover a key assumption about ordinary least square that's critical for causal inference. Let y be a random variable. Alpha is an intercept, is a constant. Beta is the slope of x. X is a random variable as well. And epsilon is the error term. Whatever textbook that you read, you see the formula of beta is given by covariance between x and y divided by variance of x. Let's derive this formula. Let's take covariance of x in both sides of the equation. Then you have cov of x and y, cov of x and alpha, and the cov of x and x. See that beta is treated as a constant, it goes outside, and the cov of x and epsilon, the error term. The covariance between a random variable and a constant is 0. There is no variation in a constant. Cov of x and x is variance of x. And this is the key assumption of ordinary least square. If x is uncorrelated with the error term, this term vanishes. Then we can write cov of x and y equal beta times variance of x. If we isolate beta, you get the formula beta equal covariance of x and y divided by variance of x. Therefore, if x is correlated with the error term, the covariance of x and the error term will be different than 0, and the consequence is the beta will be biased. We would have an additional term to add or subtract the beta. The question is, when we are sure that this term equals 0? When x is randomized, like in an experiment. Let's write covariance between x and the error term in a different way. Expect value of epsilon times x. Now let's apply the law of iterate expectation. We can add or remove these two terms according with the law of iterate expectation. Next step is to pass the x outside of the expectation. X is a random variable, but you can treat it as a constant because you are conditioned to x. If you randomize x, x will be independent of the error term, and this term will be equal 0 by definition. We show that if the error term is independent of x, the covariance between error term and x equals 0. Note that you cannot conclude the inverse. If you see covariance equals 0, you cannot conclude that the two variables are independent. Covariance is a measure of linear association. There are other types of association. Let's derive another property of ordinary least square. Let's calculate the expected value of the error term. Let's apply again the law of iterate expectation. We add the external expectation and the conditional to x. If the error is independent of x, this term equals 0. Then we have that the expected value of the error term is equal 0. This is intuitive, as some residuals are above the line and some below the line. If you sum up all these distances, you get 0.